Okay, so um, the next topic we'll talk about here. I realized that just before I started that I had incriminating evidence in the stream. It's actually a bunch of ginger cookies that have had the centers punched out. My wife is doing something with the centers, but the outside edges, pretty spectacular snack food to go along with coffee. But boy, you have too much of that, and you guys will be able to see your instructor from wherever you are on the planet. So a little self-control would be advisable there. Okay, so the next kind of view that we're going to talk about here are what we call half-sectional views. So this is a view where um, half of the view would be a section and the other half would be a typical projection view. So if we were looking at a full section versus a half section, here's our part and what it would look like. And so in the unsectioned view, we'd still see the hidden lines. Those should still be transferred down, and the center lines. But we wouldn't be sectioning through it. So the reason that these things are used is when the entire, like, they want to kind of use the best parts of a front view and a section view so that you can see what's going on. Now they're saying that with these half sectional views that you wouldn't draw the hidden lines and the center lines for the holes. Based on my experience, most firms actually would. They would still draw those hidden lines and center lines in there. So as you can see, there's even a little bit of variance, between what this textbook would say and what a firm would do. And you'd go into one shop and they would draw it a certain way, and you go to another shop and they draw it some other way. It wouldn't really make a difference as long as the whatever you're drawing is going to show correct information that will help the fabricator. Then it doesn't matter too significantly on whatever strategy you decide to employ for your drawings. So on some of the examples, we're going to see that it's going to ask for a half section view. Now, the next topic here is one that causes students in this program a fair amount of trouble and confusion. Now, I'd like to be able to say it's always the student's fault that they can't get the wrong end of the stick on this thing, but I think the theory goes if the instructor explains it well enough, the students should be able to, you know, understand what's being asked of them and and get it done right. So if you guys don't get this, it's not because you have failed. It's because the instructor has failed. So let's see if I can get you guys thinking about how this is supposed to work. And you know what? This is the first year I've done it on YouTube and actually had it recorded. So other years, I mean, you guys are all like just overloaded with all the stuff I'm throwing at you. So it's like brain overload from 9 o'clock to noon. It's no wonder that maybe the students couldn't retain it because it's just it's TMI, right? It's too much information. People just can't track it all. So you guys will be able to come back and review this. So I don't know if any of you guys like this year when YouTube or when you heard it was going to be remote instruction and you're like, should I really go to school this year? Should I just take a gap year? The instruction's going to suck. I'm going to be on Zoom all day. I'm going to get a crappy education. But now that I'm thinking about it, you guys actually you're going to get a pretty awesome education out of this. Just because all this stuff's recorded so you can come back and look at it later. So I think it's pretty cool. So what we're looking at here, we've got a hub and flange. So you can see that there's this raised bit in the middle. There's 3 keyways, and we've got 3 holes to hold this thing onto whatever material is behind. And we want to show a section. So this is called an aligned section. Now this would be in opposition to an example where instead of 3 holes, so let's just imagine that we've got something that's got 4 holes in it, or 2, right? So let's say that we've got something that's got 2 holes in it, like I'm drawing here. Okay, so if you were to cut a section through this, right? Super easy. It would look like this. I should have my holes in the right place. Okay. Right? That's how this thing would draw. If you'd be sectioned if you had 2 holes in it. Now we've got something with 3 holes in it. So do we section it like straight through? Like this? What would happen then? Well, you'd end up with this example here, right? That's the literal section through this object. And that's just confusing as heck, right? Like that makes no sense at all. Someone's fabricating this and they're like, nope, I don't get it. So what we do is we take the section. So instead of going straight through, we don't do that. And we look at the axes of symmetry for the object. And we have our section line follow one of those axes. So instead, we're going to make the section follow the axis. So it's basically a bent section. It comes on down, hits the center, runs along one of these axes of symmetry, and then out to the outside. Now, this is an unfortunate mistake that people make. They start putting in the section line here. They're looking in this direction. Bump, 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 bump. They come down here with their section graphic, and they go looking in the other direction, right? No. Basically, think of it. You're starting off with a section where both lines are, both sides of the section are looking in one direction. Well, here you're just breaking it and hinging it and rolling this thing off to the side. So it's got to be looking in the same direction. So don't make the mistake where here you take the direction of the section and you're making it look in the other way. It's got to look in the same direction as this piece up here. So keep that in mind when you're setting up your sections. So let's look at our cast iron piece here. So you've got 3 webs on this thing. Got a hub in the middle, and then we've got a little bit of toe on the end where this thing gets a little smaller. You can see these flanges up here. So the material gets thinner. Well, you can see how this section looks. See how it's got a bit of a curve in it? So you can see a bit of that curve being shown here as you translate that over, and there's the hole, there's the center line for the hole, hidden lines on each side, and a hidden line for this round slot that's in the end. So if I was going to draw a section through this thing, same principle will apply here. So for sectioning through this thing, this is full thickness material from side to the other, so we don't have to worry about that web effect. So now just object lines here for the rest of the slot and for the background of the hole, and just here to the center line. So this thing has got a counter bore on it, so the object lines continue across. So now we section this thing. Right, so now we can draw the other side of the thing, and it's going to be the exact mirror. It's going to be the exact mirror of what I drew on this side. So I'm just going to keep going here. I'm just going to eyeball it because I don't have anything to trace on this other side. Probably not going to get the proportions quite right here, so I'll be slightly out of whack with scale. Okay, so then we just draw our center lines. Now, with this hole here, there is, in fact, a center line for it. And so I would actually draw that wherever it might sit. And then same with this thing here, I'll just draw the rest of the... So in this case here, where you have a 3-spoke, you draw that section. So starting here, comes down, hits the axis of symmetry, breaks a leg, heads off to the side here, and then make sure again that the section is pointing in the same direction. So if the section is generally pointing in this direction, when we make the break for it here and then twist it over by 60 degrees, you're rotating it so you're looking in the same direction. And that's what the resulting section would look like right there. To show, yeah, this is like, why does this suck? So in a textbook here, because in the stream you guys aren't going to hear Zach's question because it doesn't come through and get sent to the stream. The question is, what is the purpose of this cluster cuss of a drawing? Right, so it's to show you what the literal section would look like and why we wouldn't draw it. So when is this aligned section process used? Anytime that you don't have 90 degree or 180 degree symmetry. So if you've got something that's got 2 spokes or 4 spokes, the aligned section isn't required. But if you've got 3 axes of symmetry or 5 or something else, then you're going to run into that. Now, I'm going to come back to this in a bit, but I'm going to look at some of these examples here. So here is one with the spoke hub rim problem. This is one that we'll be working on. But when this is sectioned, there's no need to break the section because it's at 90 degrees. So this one is easy. Some of the other examples, I'm just trying to find. So these ones here, right? You're every 120 degrees. So that's your axis of symmetry. And you can see the student's state of mind when they, right? So it's like this, it's like the Charlie Brown meh cloud. Actually, that's not even meh. That's like life sucks. Aligns. Yeah, or confused. Yeah, that's right. That's right. Depressed and confused. So in both these cases here, we've got, yeah, you got three axes of symmetry, three here, three here. Just trying to see if there's any other problems here where there'd be more. Well, so here now you've got one that's got 6, right? So every 60 degrees you've got it. Although here you could section. Oh no, let's see. This one's got a web. You guys can see it's got webs here every 120 degrees. So to make this thing, because the webs aren't every 60 degrees, and if they were, well, then you could just section through the thing and be done with it. But because this thing's got irregular placement of the webs, at least not along a 90 or 180 degree axis, then you've got to do an aligned section. And again, there's the direction of the section, right? So you start off, you know, having the section look at this direction at the top, but down here, we're going to rotate it. So just make sure that you keep your consistency with your direction of the section. Exactly. So the question was here, just so it can be recorded to the stream, what happens when you encounter something like this? So typically when you draw the top view, you're going to have one of the spokes facing straight up. And you'll run your section line, you run your section down that axis, and you can decide which direction you're going to look. It doesn't really matter which direction. Typically, if we look at our sheet layout, so let's do a little vignette of that here. So if this is your sheet, and you can elect, about which direction you want to put one of these cylindrical objects. So, if I've got this 3 flanged thing, and I'm going to put it here, then the section is going to be beside it, and the section needs to be oriented to point towards it. So there's our little hub in the middle. So we would want the section to be oriented like that. You would not want the section oriented so that the hub is facing the other way. So this would be wrong. So don't have it so that your hub is facing in the opposite direction. So right, you want to have it so that it's pointing towards your top view. So if you really wanted to draw your section in this direction, you just need to put it on the other side. Okay, so if this was your top view, so if you put your top view on the right-hand side of the sheet, then your section would be drawn to point towards it, like so. So your section should always point, the top of your section should always point towards your top view. Now, if the object is very, like there's room for it, you could, of course, put your top view above your section. That would also be acceptable, especially if you're going to draw other objects on either side. But as you guys can see, this thing could end up being pretty tall, and it might not fit in your sheet top to bottom based on the scale that you've been asked to draw a particular object at. So that's kind of what I'm getting at here. So anyway, that's kind of how this thing's going to be set up here. So we'll take another, what are we at here? 10:45. Let's come back at 5 to 11, and we'll talk a little bit more about this, and we'll get into the next assignment.